All right, strap in, everyone, because today we're going way beyond the usual suspects of our solar system like Jupiter, Saturn, Mars, and going to the ice giants, Uranus and Neptune. And these planets, they're always shown as these calm, icy blue balls, but honestly, they hide secrets way more dramatic than any sci-fi film I've seen. Think like supersonic winds and a planet literally just chilling on its side. Oh, and moons that seem like they were like plucked from a totally different part of space, ready to have your minds blown.
Absolutely. There's just so much to discover about these icy enigmas.
Welcome to Cosmos in a Pod, Space and Astronomy series. Okay, so let's start with something basic. What exactly makes a planet an ice giant? Is it like just a giant snowball hanging out in space?
That's a really great question. And honestly, it's more complicated than just like frozen water. So unlike gas giants, like Jupiter and Saturn, which are mostly hydrogen and helium, Uranus and Neptune are packed with heavier elements, stuff like water, ammonia, and methane. But here's the thing, because of the insane pressure inside these planets, these elements aren't exactly just like ice skating around. They're actually in this super dense, almost slushy state, which makes these planets denser than those gas giants I were talking about.
Okay, so dense slush, not a snowball.
Wow.
Got it. But that still doesn't explain why Uranus is, famously tilted on its side,
Yeah.
practically doing a barrel roll around the sun. So how did that happen?
Well, just imagine the early solar system like a giant cosmic billiards table. Planets are forming, things are colliding. It was pure chaos. And scientists believe that this massive object, maybe even another planet-sized body, slammed into Uranus early on, knocking it completely off kilter.
Wow, that must have been some collision. And that impact, billions of years ago, still affects Uranus today.
Exactly. That single event is likely the reason Uranus is tilted 98 degrees. So it's spinning almost perpendicular to its orbit.
Talk about a long-lasting impact. Okay, so we got Uranus, the rebellious one, tilted and spinning to its own beat. What about Neptune? What makes this blue giant so special?
So Neptune might not be sideways, but it definitely has its own drama going on. This planet has the most ferocious winds in the entire solar system. We're talking speeds over 2,100 kilometers per hour, which is faster than the speed of sound.
Hold on, wait. How can wind even get that fast? It's hard to even imagine.
It's mind-boggling, right? And that's not all. Neptune also has a super dynamic atmosphere, with storms that rage for centuries, kind of like Jupiter's Great Red Spot, but even more intense.
So Uranus is chilling on its side, and Neptune's out there throwing cosmic tantrums.
Well, tantrums might be simplifying it a bit, but the point is, Neptune's atmosphere is incredibly active and turbulent, with forces that we're just starting to understand. And just like its tilted sibling, Neptune also has this magnetic field that's tilted and off-center, which suggests some pretty complex stuff happening inside.
Okay, so both ice giants, both with wonky magnetic fields.
Yeah.
Is there a connection there? Can scientists explain that?
That's the million-dollar question. One theory is that the unique slushy makeup of these planets, those heavier elements in their dense state, is affecting how their magnetic fields are generated. But to really know for sure, we need more data, more observations, ideally a dedicated mission to these planets.
Speaking of interesting features, didn't you mention something about Neptune having a moon that orbits in the wrong direction? That sounds like something out of a space opera.
It's true. Triton, which is Neptune's largest moon, is really something else. Most moons orbit in the same direction as their planet's rotation, but Triton orbits Neptune backwards. It's called a retrograde orbit.
So it's like swimming against the current. How is that even possible?
It's a strong sign that Triton wasn't actually formed around Neptune. The leading theory is that it was captured from the Kuiper Belt, which is a region of icy bodies beyond Neptune, billions of years ago.
So Neptune, went and snagged a moon from another part of the solar system. That's pretty impressive.
It is. And here's the thing about Triton. It's not just some passive captive. It actually shows signs of geological activity, including ice volcanoes, and it even has a very thin atmosphere.
Wait, hold on. Ice volcanoes. Now that's something I got to hear more about.
Well, get ready, because this is where things get even more interesting. Remember how we said that ice giants are more common than we thought in other star systems?
Yeah, you said studying Uranus and Neptune could give us clues about other planetary systems.
Exactly. And Triton, because it was captured from the Kuiper Belt, which is packed with icy bodies, could give us a glimpse into the types of icy worlds that might be out there, orbiting other stars.
So by studying this one weird moon in our own solar system, we're potentially getting a preview of what could be light years away.
Precisely. And that's why understanding Uranus, Neptune, and their unique moons is so important for expanding our knowledge of what planets can be, both in our solar system and beyond.
This is all so fascinating. I feel like we're just getting started with these ice giants.
Oh, we've barely scratched the surface.
Yeah.
There are so many more mysteries to uncover.
I can't wait to dive in.
You know, it really is amazing to think that these distant worlds, billions of kilometers away, they hold clues to how our solar system formed, and maybe even secrets to life beyond Earth.
Yeah, it's like they're time capsules from the early solar system, just frozen in time waiting for us to decode them. Speaking of secrets, I know we talked about some of the mysteries of these ice giants, but are there any big unanswered questions that, really keep scientists up at night?
Oh, absolutely. Uranus and Neptune are full of enigmas. Like, for example, one of the biggest puzzles about Uranus is its incredibly low internal heat.
Low internal heat. But isn't it already freezing out there?
Yeah, but even compared to Neptune, which is farther from the sun, Uranus is remarkably cold. It radiates very little heat into space, far less than you'd expect for a planet its size.
So what's the deal? Is Uranus just naturally more laid back than its stormy sibling?
Well, we don't really have a definitive answer yet. Some scientists think that the massive impact that tilted Uranus on its side might have also messed up its internal heat flow.
So one single catastrophic event could have had, a lasting impact on the planet's internal dynamics billions of years later.
Exactly. It really shows you that the solar system is dynamic and, constantly evolving. And speaking of dynamic, let's move on to another big mystery. What's fueling Neptune's crazy wind speeds?
Right, those supersonic winds we talked about earlier. But how can winds get that fast? What's the engine driving this, like, cosmic hurricane?
It's a question that's puzzled planetary scientists for decades. Neptune gets way less solar energy than the inner planets, but its winds are far stronger than anything we see on Earth or even Jupiter.
So what are the leading theories? What could possibly drive winds that powerful?
Well, there are a few ideas out there. Some scientists believe that the answer lies deep within Neptune's atmosphere, where the intense pressure and unique composition might create conditions that, supercharge these powerful winds. Others think that the planet's internal heat, which is higher than Uranus's, might be playing a role.
So maybe it's a combination of internal and atmospheric factors. It's like a giant planetary weather puzzle.
Exactly. And to solve it, we need more data, more observations, and ideally dedicated missions to these ice giants.
Okay, we can't talk about ice giants without mentioning their cores, right?
Yeah.
What do scientists think is lurking deep down at the heart of these planets?
The core. It's another area with lots of speculation and not much hard evidence. The main theory is that both Uranus and Neptune have relatively small, rocky cores surrounded by that dense, slushy mixture of water, ammonia, and methane ices we talked about earlier.
So a rocky core, then a slushy layer, and then the vast gaseous atmosphere. It's like a layered cosmic cocktail.
That's an interesting analogy. But what's really fascinating is that the cores of these planets probably play a key role in creating those unusual magnetic fields.
Okay, remind me again. What's so strange about their magnetic fields?
Well, remember we talked about their magnetic fields being tilted and offset from the planet's axis of rotation?
Yeah, like their magnetic north poles decided to take a vacation near the equator.
Exactly. This weird placement suggests that the magnetic fields aren't created in a simple symmetrical way like we see on Earth. The complex dynamics within those slushy layers and the interaction with the rocky core could be creating these unusual magnetic fields.
It seems like every time we learn something new about these ice giants, it just raises more questions, like a never-ending cosmic mystery.
And that's the beauty of scientific exploration, right? The more we learn, the more we realize how much more there is to discover.
It's like peeling back the layers of a cosmic onion, only to find another onion underneath.
Hopefully without the tears. But you're right, there's so much more to explore, and these unanswered questions are why scientists are so eager to send new missions to these distant worlds.
Speaking of missions, didn't we send a spacecraft to Uranus and Neptune back in the 80s? Voyager 2.
That's right. Voyager 2 gave us our first up-close look at these planets, their rings, and their moons. It was a huge accomplishment.
But that was over 30 years ago.
Mm.
Our technology's got to be good enough to get another closer look now, right?
You're absolutely right. And the good news is that space agencies all over the world are developing proposals for new missions to the ice giants.
Now that's exciting. Tell me more about these potential missions. What are scientists hoping to learn?
Well, one of the most exciting prospects is a dedicated mission to Neptune's moon Triton. Remember how we talked about its backward orbit and how it's probably captured from the Kuiper Belt?
Yeah, it's like Neptune's adopted child with a really interesting past.
A great way to put it. A mission to Triton could give us incredible insights into the icy worlds that are in the outer solar system and beyond.
So we could learn about Triton's composition, its geological activity, and maybe even figure out how it was captured by Neptune.
Exactly. It would be huge for our understanding of icy worlds. There are also proposals for orbiters that would study Uranus and Neptune in much more detail than Voyager 2 could.
What kind of information could we get from an orbiter mission? What are scientists most excited about?
Oh, the possibilities are endless. Imagine mapping the gravity fields of these planets, studying their atmospheric dynamics in detail, maybe even looking beneath the clouds to understand their internal structures better.
It would be like having a permanent robotic scientist out there, constantly sending back data and helping us solve those mysteries we talked about.
It would completely change our understanding of ice giants. And remember, what we learn about these planets in our own solar system can help us understand all those planets orbiting other stars that have been discovered recently.
Ice giants seem to be pretty common in other planetary systems. So by studying our own, we're basically getting a sneak peek into the diversity of planets across the whole galaxy.
It's like having a cosmic laboratory right here in our backyard. Who knows what incredible discoveries are waiting for us as we continue to explore these fascinating worlds.
You know, it's wild to think about how these planets that used to be just like fuzzy dots through telescopes are now helping us understand just how vast the universe is and all the different types of planets out there.
Yeah, it's true. Uranus and Neptune really show us that our ideas of what a planet can be are way too limited. We often think of planets like Earth or Mars, but these ice giants show just how different planetary evolution can be.
It's like nature saying, think you've seen it all, not even close.
Exactly. Those crazy environments, their unique compositions, those wonky magnetic fields, it all forces us to rethink how planets form and change over time.
And it's not just about the planets themselves, right? These ice giants also tell us about how our whole solar system came to be.
Definitely. Remember we were talking about how Triton might have been captured from the Kuiper belt? If that happened, it would really shaken things up in the outer solar system, like changing the gravitational dance of everything.
Yeah. So it's like a game of cosmic billiards, with planets and moons bumping around for billions of years and finally settling where they are now.
Exactly. By studying their orbits, their compositions, and how they interact, we can start to understand how our solar system evolved.
It's like a giant cosmic detective story. And these ice giants have some of the biggest clues.
And as we keep exploring, I'm sure we'll find even more surprising connections and insights.
Makes you wonder, what else is hidden out there in those icy depths of the outer solar system?
I'm sure there are tons of wonders just waiting to be discovered. Like, imagine what might be under the frozen surfaces of some of those moons.
Like giant hidden oceans of liquid water.
Hmm.
Is that even possible, that far from the sun?
It's not just possible, it's very likely. And those oceans, if they're there, could have life. Life that evolved in total darkness, powered by the moon's internal heat instead of sunlight.
Whoa, that's mind-blowing. Life evolving in a completely different way than we know here on Earth.
It just shows you that the universe is full of surprises. Life might exist in places we can't even imagine.
Okay, so what's next? How do we actually unlock those secrets and search for life in these extreme environments?
While sending dedicated missions to Uranus and Neptune are at the top of the list for a lot of planetary scientists. Think about it. Mapping their gravity, really studying their atmospheres, even sending probes below the clouds to analyze those icy layers.
It's like we're about to set sail on this huge voyage of discovery into the unknown.
And I'm absolutely certain that this journey is going to be packed with discoveries that will challenge our understanding of the universe.
I can't wait to see what the future holds for ice giant exploration. Maybe one day we'll even be talking about sending humans to these faraway worlds.
Now that would be incredible. But even with robotic missions, we're about to enter a new era of discovery. And I truly believe that Uranus and Neptune will keep surprising us for years to come.
Couldn't agree more. Well, I think it's time to wrap up our deep dive into these ice giants.
It's been awesome exploring these amazing worlds with you.
Thanks for sharing all your knowledge and insights with our listeners. For everyone who wants to learn even more about Uranus, Neptune, and the outer solar system, make sure you follow and subscribe to Cosmos in a Pod and check out our YouTube channel for awesome visuals. Until next time, keep looking up.